Okay, this is the video solution for topic 6, normal acad 10 series on chemical bonding. Question number 1. Which statement about ionic compounds is correct? About ionic compound is correct. So first one, they form by sharing a pair of electrons. No, sharing is for covalent, not ionic, so it's wrong. They conduct electricity as they have free moving electrons. Now, ionic compounds conduct electricity by the mobile ions, free moving ions in molten aqueous state. So they do not conduct because of electron. C. They do not dissolve in water. They do not dissolve in water. No. So generally, ionic compounds are soluble in water. So answer is D. Okay, this is a typical property of ionic compound. They have high melting points due to strong attraction between the ions. The opposite charge ions have strong attraction, so they have high melting point. Answer is D. Question number 2. Which statement about ionic compounds is correct? Now, if you look through here, first one, easily move, differentiate, obviously not. They are very hard and strong also. They conduct electricity when they are in solid. No, they conduct electricity only in molten and aqueous state. Now, what's different between molten and aqueous? Molten means melted, and aqueous means dissolved in water. So please remember this thing: dissolve in water. Now, they have high melting point. Yes, this is a typical property of ionic compound: high melting and boiling point. And most of them can dissolve in water. Question number 3. The dot and cross diagram shows a molecule of hydrogen chloride. As you can see that they share a pair. So this is actually covalent bond between them. So in a molecule of hydrogen chloride, the hydrogen atom and chloride atom share a pair of electrons. Okay, looks like correct. Pair of electrons. B. They share a pair of proton, obviously not proton. Proton is in the nucleus, not shown in this dot and cross diagram. Dot and cross diagram only shows electrons. And the center is actually a symbol. Okay, no need to draw nucleus, just a symbol in the center. That's all. Right. So giving, taking is not true. Giving, taking is all about ionic bonding. So answer is A, sharing a pair of electrons. Sometimes they can share two pairs. For example, when oxygen they bond, they form like this dot cross, right? Okay, so this oxygen share 2, and this their oxygen share 2. So they actually have two pairs. Okay, possible. Number 4. Covalent bonds are formed when electrons are what? Obviously, covalent bonds are formed when the electrons are shared. Transfer, it means ionic. So transfer refers to ionic. Please remember that. And most covalent compounds have what electrical conductivity? They have low electrical conductivity. Okay, so most covalent compounds do not conduct electricity. Unless you're talking about, for example, hydrogen chloride dissolved in water. When they dissolve in water, they form H+ ions and chloride ions. Very unique. This is a covalent molecule, but they can form ions in water. That applies for all kinds of acids also. So long you produce hydrogen ions to give acidic property, you also can conduct electricity. So take note that acids are good conductor of electricity. But generally, covalent molecules are not good conductor. Alright, because they don't have ions. Question number 5. Which change takes place when an atom becomes a positive ion? Positive ion. So for example, X is atom. For a positive ion, you must give away electron. So this means what? Give away electron or lose electron. Okay, so answer is B. Electron is being removed. Now, which change occurs when atom forms a positive ion? Same thing. It loses electron. Now, we never gain proton. Protons never change in the nucleus. So a proton will never change in any atom when they form ion. Only electron gain or lose. If you gain electron, it becomes negatively charged. If you lose electron, become positive charge. In this case, to form positive is lose electron. Same case as the previous question. Okay, next question here. Structure question number 1. The dot and cross diagram shows the arrangement of all electrons in a molecule of compound Z. So Z is made up of 3 atoms, 8 proton, can see 6 proton and 8 proton. So what happened is, name Z. What is Z actually? Now, if you look at the periodic table, 6 proton refers to carbon. okay, carbon, and 8 proton refers to oxygen. So 1 carbon, 2 oxygen, obviously CO2, and the name is carbon dioxide. So you can always use a proton number to identify the elements in the periodic table, and by combining the 3 different atoms together, you get carbon dioxide. What type of bonding is present in Z? They share, right? So it's covalent bonding. Next, draw a dot and cross diagram to show arrangement of all electrons. Take note of this, all electrons in the molecule of CH4. So first of all, let's look at C. C is 2, 4. Okay, 6 proton, 6 electron. Configuration is 2, 4. 2, 4 means it needs 4 more. Needs 4 electron. Therefore, it will share 4. Share 4 electron. So all the 4 electron will be shared. And hydrogen is a single one. So you need 1 and share 1. Share the 1 and only. So what you need to do is draw the dot cross diagram. So let me draw the outer shell. Now this is C, hydrogen, 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 hydrogen. There are 4 hydrogen. Because hydrogen can only share 1, but carbon must share 4. So they need to have 4 hydrogen in order to share back with the 4. So I have hydrogen, carbon, hydrogen, carbon, hydrogen, carbon, hydrogen, and carbon. So the carbon is dot. So inner shell is 2 dots here. Okay. So this is actually CH4. And X is electron of hydrogen. And the dot is electron of C. You can see the inner shell of C has dot. So it's dot is electron of C. So this is the correct dot and cross diagram. Now when you draw in an exam, try not to draw the hairy lines. Make sure is draw a nice circle as round as possible, but no hairy lines. Okay, try to eliminate hairy lines. Okay, question number 2. Aluminum atoms can form Al3 plus ions, and oxygen can form O2 minus. Describe in terms of electron how oxygen atom becomes an oxide. In terms of electron means that whether electron is gained or lost. So how does oxygen atom become oxide? So oxygen atom gains, the keyword is gains 2 electron each to form an oxide ion. Okay, keyword gain 2 electron each. So every atom, each oxygen atom will gain 2 electron. The formula for aluminum oxide. Okay, let's recap how to do. Aluminum Al3 plus O2 minus. Now, when you write a chemical formula, you try to balance the charges. The charges not the same, you cancel each other and cross each other. See, for example, 3 plus and 2 minus. What you do is you remove the plus and minus first. Okay, then I cross the 3 over to the oxygen and cross the 2 to the aluminium. So they exchange Al2O3. So formula is Al2O3. Okay, if you don't know how to write chemical formulas, please go and refer to my video that give you a detailed explanation how to write the formula. Next one, I think the last question. Question number 3. Now, this is a typical analysis of a mineral water. So now you know that mineral water contains really minerals inside, like cation, anion, and so on. So definitely mineral water is not pure. It's not 100% pure water. It contains a lot of salts inside, different kinds of salts. Salts doesn't refer to sodium chloride only. Okay, all these chemicals are considered salts. So which ion is present in the lowest concentration? So you look through milligram per dm cube. That means milli means 1 over 1,000. Okay, it's milligram. So it's a very tiny amount per dm cube. Now 1 dm cube is equal to 1,000 cm cube. So dm cube is about, okay, it's exactly 1 liter. Okay, 1 liter. So this is very trace amount, tiny amount. So lowest concentration obviously is 0.5. But you don't tell me 0.5 lah, because it's ion. So you must write down there potassium ion. Okay, potassium ion. How do you know it's ion? This is ion. All these ions. Now, in answering question, usually you write names. Okay, don't write formula unless you're asked to write formula. How many metallic ions are there? Metal ions are there present. So metal ions are all positive ions. So look carefully. Calcium is a metal, magnesium is a metal, potassium is a metal, sodium is a metal. You can confirm by looking at periodic table. There are 4 of them. They are metal ions. So it's 4. Alright, in this case, you can write a numeric 4 because ask you how many is a number, so you can write 4. Some of the magnesium ion and chloride ions could have come from magnesium chloride. So deduce the formula of magnesium chloride. Now look at what they've given to you. Magnesium and chloride. Mg2 plus Cl minus. Okay, let's try again. Mg2 plus Cl minus. The charge must be balanced, but they're not equal, right? So it's 1 is 2, 1 is minus 1. So what you do is remove the plus and minus and cross the number. Alright, cross the number. So since it's a 1 for chloride, crossing over, there's nothing to write. So it's Mg, don't need to write the 1. And the chloride, you need to write a 2 at the back. Alright, so MgCl2. Now, state how the dry residue is obtained from the mineral water. Look at this. What does it mean? You're actually boiling off the water. Okay, evaporate by heating the high temperature, so the water will evaporate. In fact, water boils at 100 degrees, right? So water's boiling point, okay, water boiling point is 100 degrees Celsius, but it's impure. It has a dissolved minerals inside, so the boiling point is slightly above 100. So impure water, take note of this, water boiling point is slightly above 100 degrees Celsius. So probably around 105 degree. Okay, depending on how much impurity dissolved in it. Alright. So this 180 degree residue, dry residue at 180 degree means I give you a hint that you are heated until dryness. So it's evaporate to dryness by heating. If you don't heat, how do you get 180 degree? Okay, so you just heat directly, heat until it dry. Right, next one. Mineral water is tested using the universal indicator, and what color we expect to see. Now let's revise the color of universal indicator. The colors are ROY, GB, IV. Now red, orange, yellow, green. Green is neutral, blue, indigo, violet. Alright, so pH 1, pH 14. This is 3, 5 is about probably 10, maybe about 9 or 10, and this is about 12. Okay, around there. So down here you can see that the pH given is pH 8. Definitely it's not green, it's more towards blue. So I can say that the color should be blue color, bluish green. So how does it tell? What does it tell you? What does it tell you about the mineral water? Is slightly or weak alkaline, slightly alkaline in nature. Okay, slightly alkaline in nature. Right. So if it's around 12, above 12 is a strong alkaline. If it's below 7, just around 4 or 5 is called weak acidic, slightly weak acidic. But if it's 1, 2, 3, it's strongly acidic. All right. The last question here. Now you're given all the formulas. You're supposed to write the chemical formula of the compound. Calcium oxide. Let's look at calcium. Where's my calcium? Calcium is here, oxide is here. Now this is the easiest formula because calcium is 2 plus, oxide is 2 minus. And since the charge are equal and opposite, you simply cancel them out. Right? 2 plus, 2 minus cancel with CaO. Sulfuric acid. Sulfuric acid is hydrogen ions and sulfate ions. Now look at the number here. They are not equal and opposite, so you need to remove the charge and cross the number. Okay, no number to cross for hydrogen, so it's H2SO4. In fact, you're supposed to remember the formula of acids. This is sulfuric acid, please remember that. Okay, and HCl is hydrochloric acid, and nitric acid HNO3. Now these are the very commonly found acids in the exam paper, so make sure you know them. Nitric acid, okay, not nitrate acid. Right, you need to know 2 alkalis. Okay, very commonly used one is sodium hydroxide, NaOH. This is sodium hydroxide. And this pH is about pH, maybe about pH 13. Okay, and these three acids are about pH 1 to 2. Now another weak alkali is aqueous ammonia, usually written as NH3 bracket aqueous, call it aqueous ammonia. Okay, basically it's ammonia gas dissolved in aqueous ammonia gas dissolved in water. This has a pH about 10. Alright, so if you wonder whether didn't remember this, yes, please remember the facts. Okay, so you may want to write this thing down somewhere and then you remember them. Okay, let's move to finish out the question. So sulfuric acid is H2SO4 and aluminium sulfate. Aluminium and sulfate. Okay, let's do the working here. Aluminium 3 plus, sulfate is SO4 2 minus. Now take note of this one. SO4, okay, this is called polyatomic ion. Polyatomic ion, there are 5 of them that you must memorize the formula. Okay, let's recap what you need to memorize. One is the sulfate, which is given here. How about nitrate? NO3 minus. And then there's carbonate, CO3 2 minus. Alright, and then there's also hydroxide, OH minus, and ammonium. Ammonium is NH4 plus. Okay. Now, if you have not memorized this, please write it down and memorize it, including the spelling. And nitrate and sulfate. Okay, all these are polyatomic. If you need to have a multiple of them, if you need to put a number behind them, you always bracket them. So look at my sulfate. To balance this formula, 2 minus and 3 plus, you remove the charge. The 3 will move to the back and the 2 will move to the aluminium, right? So it's Al2. SO4 is a polyatomic, so you put a bracket before you put a number behind. Okay, so these are polyatomic ions. You always bracket them before you put a number behind. Okay, always bracket before put a number behind. So answer for aluminum sulfate is Al2 bracket SO4 bracket 3. Okay, now take note, all these numbers are subscript. It must be smaller, about 1/3 the size, and it's slightly below, alright, at the bottom part, subscript. Okay, that's all for this chapter. And these are the formulas and some things you must memorize.